going on. Alice, you had a question?
Oh, we were just wondering why there's only like one female.
Yeah, we had this conversation. There's just not that many prominent female mathematicians over history. There are various reasons for this.
Wait, which is the female?
It's true. In the last 100 years, there's tons. But,
We were just looking.
yeah. Good.
You didn't have this conversation with me.
It was you and Aditi, I thought. Or no, it was you and Aditi. Yeah.
I was
Okay,
Why
yes.
are so many Isaacs? Like,
Why are
there
some of the
lots
what?
Isaacs. You guys are popular?
You
I
know,
think it's a cool name.
you pretty, yeah, pretty.
there-
It used to only be like 5 names. It was just like the first 5 names of the Bible. Like those are all your choices. That's it. All right.
There are like more than five names in the Bible.
Good. So this is the formal definition of limit. What can we do with this? With this definition, I can prove formally that a limit is what we think it is. Let's do one, shall we? Let's take the limit as x approaches 4 of 2x minus 3. What is this?
We don't know. We haven't proved it yet.
This is 5.
What?
Again?
Wait, what just happened?
Oh, that's kind of boring. Oh well, too late. Do you want me to change it?
No.
No. Okay, good. So this limit is 5. Let's make a picture. 2x minus 3. Boom, boom, boom. 4. And 2. Okay, here's my function. Good. Or here's a graph of my function. So, what does it mean, we now know, when we say that the limit as x approaches 4 of this function is 5? Well, what that means, because I'm talking the green marker, what that means is that for any possible challenge whatsoever, and this challenge comes in the form of some number epsilon, what that means is that if you challenge me with some number epsilon, then you are demanding that I be within epsilon of 5. And I meet that challenge by getting close enough to 4 to make that true. And when that close enough to 4 is articulated as a single number, delta, and delta represents how far away from form we're allowed to go. In words, we often say, if you want to describe the formal definition of a limit without actually writing any algebra, but just doing it in words, we say that I can make the values of this function arbitrarily close to 5 by taking x values sufficiently close to 4. And this kinds of sentences you did find in Newton, which is pretty much the formal definition. But only when pressed did he kind of respond with this kind of way of talking about it. All right. So therefore, based on this formal epsilon delta definition of limit, what is it really when I want to say that this limit is 5? What precisely is it that I need to prove? So just like Eric, regurgitate the definition back to me, but this time with like numbers plugged into the right spots.
For any epsilon greater than 0, there's this delta greater than 0, such that for any x minus
But what's a in this case?
4
Yep.
is less than delta greater than 0. Then f of x, so 5 minus
Yeah. Then the distance between the function and 5 must be less than epsilon. Yep. If I stay pretty close to 4, then my y values will stay pretty close to 5. That's what this says, right? if the distance between x and 4 is less than delta, then the difference between my y value and 5 will be less than epsilon. That's the claim that I'm making. Okay, so how can we prove that this is true? Well, first what we must do is we must discover what the dependence is between epsilon and delta. Using common sense, if you give me some epsilon, then I'm going to have to respond. I respond with some kind of delta, right? But if you give me a really, really, really small epsilon, then I'm going to have to respond with a really, really small delta, right? Shall we experiment? Suppose you give me an epsilon of 1/2. Using common sense, what should my delta response be in this case? 1/4. Gerhard, where'd you get 1/4 from?
Well, the slope is 2.
The slope is 2. So based on the kind of conversation we already have, since the slope is 2, if I want to stay within 1/2 along the y's, then I must stay within 1/4 among the x's. Okay, what if you give me an epsilon of 1/10? What should delta be?
28.
Now it seems like common sense says that delta should be 1/20th, right? So I'm going to stay within 1/20th, my y has to be within 1/10. Alright, so there seems to be a pattern here. The delta is going to depend on the epsilon. How precisely the delta depends on the epsilon, you can either figure out by just duh, or you can calculate algebraically. We're going to do the second one. And what I insist, therefore, is that you go into a discovery phase. As we did last semester, the discovery phase is not actually part of the proof. It is the scratch work before you can begin the proof. And in the discovery phase, we will discover what the dependence is between epsilon and delta. Okay, well, think about what happens when I go to actually do this proof. When I go to actually do this proof, somebody is going to suggest an epsilon. I have to respond with a delta. And then, about that delta, I must prove the following sentence. And what I do is I start pretty close to 4, and then I need to eventually show that this is true. And when we prove a conditional, we assume the antecedent and derive the consequent. All right, so looking ahead, you sort of realize that this is the big thing that ends up being the thing that we have to prove. And how do we prove this? Well, so since that's the thing that we have to prove, we're going to work backwards and start from there. So in the discovery phase, you start with the thing that you're trying to prove, and you work backwards to discover which x values will land you between the parallel lines. All right, so that's what we're finding right now. We're calculating algebraically what kinds of x values will indeed land me between 5 minus epsilon and 5 plus epsilon. How do I do this?
Split up the absolute.
There's a couple things you can do. One thing Samin suggests, you don't have to do this first, but you might as well, is to plug in for f of x. Just plug in the actual function under consideration. That seems like a good idea. Now what?
Well, first get rid of friends.
Okay, I can do that.
You can do like.
Now split up the absolute value.
Yes, the absolute value.
Yeah, there's no right answer here. All these things work fine. Let's just split up the absolute value. This is not how we usually do it, but that's what someone said, so why not? We know that if the absolute value of something is less than epsilon, then that means that thing must be pretty small, like between negative epsilon and epsilon. Is everyone cool with that?
Yeah.
All right, so just solve for x. Wait, is this right? Yeah. Okay, so a couple lines of Algebra 1 later, here I am. Where I am is that this is true, or if this is true, then x must lie between 4 minus epsilon over 2 and 4 plus epsilon over 2. All right, and what makes this particularly nice is that since this is a line and everything's nice and easy and pretty and boring, all of these steps in this proof are reversible. So though we started here and went here, it is also possible to start here algebraically and get back here. And therefore, what's emerging from this work is that it is precisely when x is between 4 minus epsilon over 2 and 4 plus epsilon over 2 that I do land between the parallel lines as required. Okay, so therefore, what does it seem like I should set delta equal to? Yeah, so the conclusion of discovery phase is set delta to be epsilon over 2. Because that's what this says, right? Epsilon over 2 is exactly how far away from 4 I'm allowed to be. And this is exactly the pattern which you were pretty much had already conjectured, right? How were you guys doing this? You were just taking that number and dividing by 2. So someone's going to challenge me with a tiny, tiny, tiny number, and my retort is just going to be, hey, I take half of whatever you give me. Yo.
We've already defeated this, but just taking one last final stand. Can't we say that the discovery phase is sort of the proof?
Yes.
By going
Yup.
by being able to go to the end of the.
Yep. But I don't care. I'm making you do it anyway because I
Make a theorem called the theorem of reversibility or something.
No. What I want you to do, what I want you to do is to engage in the actual proof. And in the actual proof, it is very similar.
It's the same. It's the same thing.
It's the same thing for this case.
I should just
What?
It's the same thing for everything.
No, not true.
Okay, well everything does.
So good. Anyone who's complaining will get a special test with a hard problem for which it's different. So like quadratics. You ever do a quadratic root? It's pretty hard.
Because you have to prove both.
It's hard. Yeah, it's really hard. It doesn't go both ways. It doesn't reverse. That's the thing. Lines are easy. Lines, it reverses. Other functions, it doesn't. We're going to see an example of that in a minute.
Okay.
Anyway, now comes the proof. Now the actual proof begins. How does this actual proof work? What's the first thing I do when I try? What's the very first thing that happens? If I want to, this is the claim that I'm making that this limit is 5 is a claim that starts with for all epsilon greater than 0, blah 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 blah. So how do you do a proof like that? Like for example, if I want to prove something about all triangles. Pick an arbitrary triangle. So this proof begins by pick an arbitrary what? Epsilon. Pick an arbitrary epsilon. So somebody shouts out an epsilon. What is my response to that arbitrary person? Yes, correct. Tell him to shut up by responding with half of that. Exactly. Your response to that person is, haha, let delta be epsilon over 2. In other words, your retort to that person is half of whatever the challenge number that they gave you. And then, once I have done this, what remains to be proven? What I must prove is this sentence, that if the absolute value of x minus 4 is less than delta, then the gap between the function and 5 is less than epsilon. This is what has to be proved. Okay, so how can I prove such a sentence?
Reverse algebra.
Reverse the.
Reversing discovery.
Start with
So
d equals d over.
You can
Start
start
with
with
delta.
It is a conditional. How do we prove conditionals?
Start with the antecedent.
Yes, you assume the antecedent and you derive the consequence. So we will assume that the absolute value of x minus 4 is less than delta, and then we will try to derive this algebraic fact. Okay, how? Do that.
First, D is
Yes, first Emma notes that delta has been defined to be epsilon over 2. Okay, what now?
do math.
Yeah, you could split up. There's actually a faster way.
You can do this 2 times.
Yeah, you can just, Samin says, you can just stick the 2 in, right? Multiply both sides by 2, 2x minus 4 is less than epsilon. And now,
It's like 2x minus 8.
yeah, that feels like a rule of algebra, right? Put the 2 in the absolute value. 2's are pretty much harmless. So this is 2x minus 8. Everybody with me? Going kind of fast, running out of time. What now?
Now just get section.
Yeah, just rewrite it as absolute value 2x minus 3 minus 5 is less than epsilon, and we're done, right? We've just shown that the difference between the function and 5 is less than whatever arbitrary number I was challenged with. Okay, congratulations. You just did your first formal epsilon delta proof using the formal definition of a limit. Okay, shall we do something harder?
No.
Yeah, no, it seems like this was the whiny class that was demanding something harder, so we're going to do something harder now. All right. I will give you, no, you're not whiny. Actually, I've been tutoring other students lately that are not in the magnet, and it's like, oh my god, students are amazingly great. I was like, all I was thinking is, wow, I'm so spoiled. My students are amazing. All right, good. If anyone who I'm tutoring is watching this, you're also awesome. Okay, so, Calvin, let's do a problem. Here is the problem. I'm going to give you a function, and the function is x minus 2 over x minus 2. Okay, and here's my claim. Oh, well, actually, before I even make the claim, I'll just ask you, what is the limit as x approaches 2 of this function?
1/2. Done.
1/2. Done. You are correct. Because, of course, like the x over 2's cancel, right?
Yeah.
And this function is really just the 1 over x function where x can't be 2. I include this only because I am still trying to, obnoxiously assert that the behavior of the function at 2 is irrelevant. Okay, so I agree. I think this is 1/2. And what we're going to do now is we're going to make a very large, neat, high-quality diagram of this function.
Large. Am I gonna need more space after this, or is this like the last thing we're doing? Just
I don't
want to know how large.
You know,
So I shouldn't do it that much.
most exciting part of the video, watching me graph. All right.
That point.
That point is supposed to be 1, wait, actually, what am I doing? I don't even know what that point is supposed to be. Thank you. That point was supposed to be 2, 1/2. There we go. Better? And what we know is that this function has a hole here, right? Okay. Now, I think we are good. Do you guys have what I have? Okay. Now, if I ask you to, what makes this function a little bit more difficult than the previous functions that we've been working with?
It's not a line.
It's not a line, yeah. How is that relevant that it's not a line?
You said it would be the same way backwards.
Yeah, Busis, talk to me.
Also, the distance, the delta distance on the left and right aren't actually the same anymore.
Yeah, say that again a little louder.
The delta distance on the left and right aren't actually the same anymore.
Yeah, things are going to get more complicated now somehow because the function is like not symmetrical. All right, so this is actually just like too hard, right, for you probably right at this moment. Well,
the smaller delta.
yes, he figured it out already. It's not that hard. But what I'm going to do right now is I'm going to, instead of doing this problem in general, I'm going to give you a particular epsilon, which is hard enough. And what I would like you to respond with is the appropriate delta. And specifically what I want is the largest possible delta which works. Because if you just say delta equals 0.00001, like that will work. So that's cheating. Can't do that. You guys understand what I'm talking about? For any particular delta, any smaller delta will also work. Okay, so go, figure it out. So it helps if you draw a picture, right? I mean, what's really going on here? You might work together and stuff too, man.
It's like 1 it's like 0.6 or 5/3. 5/3 versus 5/3, and it's like minus 2 minus those.
Let's go around. Board.
Wow, you erased it?
I did.
Oh.
No one can pass
You had the flip notes.
No one likes that. Some people like it. I know. I mentioned that. No. So won't you just pretend? I was talking about the other one.
As long as we don't all simultaneously watch this video.
So, T is 2.
I hurt my finger.
But that's the
Okay, so I have these nice lines. Like, what's going on? Basically, I need to figure out what x values will land me between these lines, right? This is not so hard. Oh, by the way, what is 1/2 plus a 10? Yeah, that's just 3/5. And 1/2 minus a 10th, that's 2/5.
Yeah.
So hopefully you figured that out already. So that suggests that maybe I should figure out what these points are over here, right? What is that point?
5/3, 3/5.
Yeah, this is the 1 over x function, so if the y value is 3/5, when the x value is 5/3. So 5/3, 3, that even looks kind of right, sort of right, ish, close enough. And how about this other point? What's this other point gonna be? That doesn't look so right. Look, actually both look kind of awful. Let's fix the graph in retrospect to be more beautiful. This is supposed to cross at like 2.5, right? So there we go. So yeah, so that point is 5/2, 2/5, and that, what? That's supposed to cross at like 5/3. Yeah, 1 2/3. So we have something that looks kind of like that. All right, so I'm kind of done, right? Am I done? Kinda. What's the significance of that? Where am I allowed? So thus, where am I allowed to be on the x-axis?
Between 5/3 and 5/2.
Yeah, between 5/3 and 5/2. Here's 5/3, and here is 5/2. But I'm not allowed to say between 5/3 and 5/2 because delta is a single number. And thus, what is the largest possible delta which works in this situation?
1/3.
1/3. I agree. It's 1/3. This is a little bit subtle. Some of you might be saying, "Oh, is it 1/3?" Maybe it's not that subtle. It's 1/3 because I have to pick the smaller of the two numbers, right? I must be conservative and pick the smaller of the two numbers because I must insist that all of the x values land between the parallel lines. So I'm going to go, even though I could go out all the way to 5/2, I'm only going to go plus or minus a third. I'm going to go between 5/3 and 7/3. You guys see what's going on here? And as long as I stay between 5/3 and 7/3, I will land between the parallel lines. Okay, so in this case, we set our delta to be, the answer to this problem is the largest possible delta that works is 1/3. All right, let's actually prove that this is true. Oh, by the way, you could have done this algebraically by saying when is 1 over x between 1/2 minus a 10th and a half plus a tenth.
That's what I did.
That's what you did. And if you do that, well, you just get, this is 2/5, and this is 3/5. And now what? Do flippy flippy. Yeah, you can reciprocate through this inequality as long as you know that x is positive, which it is. So you get 5/2 is greater than x, which is greater than 5/3. And greater than symbols give me a headache, so I will rewrite this as 5/3 is less than x is less than 5/2. So I could also have solved this algebraically versus graphically. Alright, now I would like to prove that this actually works. In other words, what I would like to prove, what I would like us to all prove right now, just to give you a taste of how difficult this is, show that if the absolute value of x minus 2 is less than a third, which is another way of saying if I'm within 1/3 of 2, then what? Oh, we have like 2 minutes. Then the absolute value of f of x minus 1/2, no, the absolute of x minus, minus 1/2 is less than, what was the epsilon I challenged with? 1/10.
Good afternoon,
Do you guys see this?
Tomorrow there will
Crap.
be a
All right, we have a
representative
minute and a half to do this
from
proof. It's actually pretty hard.
Here to sell youth
How should we begin?
cruiser smart trip card.
People on the internet, this happens every class.
In order to
Antecedent.
buy a
So,
card,
we
you
will
do need to
assume
be able to
that the absolute
prove
value
your
of x minus
age
2 is less than a
and
third.
residency.
Okay, what
So you
now?
would have to bring in your birth
Algebra.
certificate, passport, or a state-issued ID of some
Someone say something,
kind,
Gil.
your learner's permit
Take
to
over.
prove your residency or your driver's license. Again,
Pastor.
there will be someone during both lunches
Check
tomorrow
that.
here from Ride-On selling the Youth Cruiser Smart Trip card if you're interested. Also,
Get rid of the absolute values, okay?
all school-sponsored after-school and evening activities have been canceled for today.
Okay, what else? Keep going, what now?
School buildings will remain
Add
open and
two.
scheduled community use activities in school buildings
So
will
that
occur as
becomes
scheduled.
5/3
Again,
and
all
7/3.
after-school and evening activities are canceled.
Okay,
Thanks and have a great
but I
evening.
actually
Please
don't
be
want it
careful
to be
going home.
between 5/3 and 7/3. What do I want?
Cut it down to 5/3 and,
I want it to be 5/2. So now I pull a very strange move, which, as all of you people were saying, this is not bidirectional, this one, Matteo. This is a little bit subtle. Is it valid logic that if x is between 5/3 and 7/3, that x is between 5/3 and 7/2?
Of course.
Yes, that is true, but that does not work in the other direction. You with me? Mm-hmm. All right, finishing this off. This is still more work to do. What do we do now? What next?
Put the function back. Put the function.
Wait, is it 5/2?
is it
Oh, 5/2, 5/2.
Oh, wait, yeah.
Okay, now what do we do?
Flip.
Now reciprocate. If we reciprocate, we get 3/5 is greater than 1 over x, which is greater than 2/5, otherwise known as 2/5 is less than 1 over x is less than 3/5. What now?
Make it so it's
Multiply x, times that x, by x minus 2.
Wait, what? No. Forget about that. It's something we need to do right now. We're almost done. We're 2 lines from being done.
split 2/5 and 3/5 into a half minus 1/10 and 1/2 plus 1/10.
What?
Okay, yeah, we could do that, I guess. Yeah, so he says just rewrite 2/5 as 1/2 minus 1/10 and 1/2 plus 1/10. And I guess we could probably just stop there, right?
Or we could put back the x minus 2.
If you really wanted to finish it off, you could subtract a half. And then you get negative 1/10, 1 over x minus a half, 1/10. And now that shows that the distance between 1 over x and 1/2 is less than 1/10. All right, do you guys get it? This is a taste of how hard epsilon delta proofs can be if you deal with anything other than lines. Because you have asymmetric deltas and you need to pick the smaller of the two and the thing doesn't go bidirectionally. We are going to stick basically to doing epsilon delta proofs only with lines in this class, but maybe if you want to try a challenge, you can try something like quadratics. It's pretty hard. All right, any questions? Wait, no one leave yet? I have to give you a worksheet, and then I will see you on Wednesday.
Is this like homework?
If you have quadratics, you're still going to be on time. And people on the internet are gonna think this quadratic person, they're gonna think the truth actually, that this quadratic person is crazy.
That was like the first. That was the first thing she said.
Okay, is that off yet or still up?
No, we have like 2 minutes.
All right, good. Bye, internet. That was Analysis 1A, Calculus Class Lecture 2. I'll see my millions of followers next in 48 hours. Here we go.